Welcome everyone. Actually, you might seen this presentation last year, so it's kind of a repeat from last year because of the change in the program, at least the first part. So my name is Csaba Fitzl, and I will talk about exploit generation automation with WinDGB. Who am I? I'm a blue teamer. I'm playing part in an incident response team for the past 5 years. I also like to do security research, blogging, although not that much blogging for the past couple of years. Since I have a son, and I also have a wife, and I like to do hiking. So this picture was actually made in the Alps a couple of years ago. So what's the challenges with exploit writing? Well, there are a lot, but some of them. So it's time consuming. It can be really time consuming, even for the very simple exploit ones, for like simple buffer overflows. So it's a heavily manual intensive process. You usually go find the memory layout, try to browse in your debugger, what is where are your buffers, and so on. Finding bad characters for a given exploit or a given application, that's also a pain, usually, and it can take a lot of time to find those, to go and find them one by one. And also, the usual process is, why your exploit doesn't work, you start the process, attach your debugger, crash it, analyze what's there, modify your exploit, start over and over and over, and then you realize, oh, I did a typo, okay, let's do it again, attach, break, whatever, and it can take a lot of time. So, and as we are humans, we make errors during the exploit development, and even for like simple buffer overflow, we can, although it's a lot of time to do this, it's quite well-defined steps what you need to go through for like basic buffer overflow exploit. So what you usually do when you develop a buffer overflow is you find the EIP overwrite location. So you know that you can control EIP for the exploitation, and you try to locate, okay, where is this location in my buffer? Then you will start to check the memory layout of the cache or the application. Where are your buffers in the memory? Where are the registers are pointing to, if you can refer any of the registers to point to your buffer, and so on. So that takes time as well. Then you need to find a way to jump to your code, to the buffer, usually with one of the registers. And then you generate a shellcode, usually with Metasploit, or you write your own, put it all together, and hopefully it will work. There can be some variations, but for most of the cases, these are the main steps you will really go through when developing a buffer overflow. So I was thinking, okay, if it's so well-defined, and you can read a lot of articles about explaining how to write a simple buffer overflow, can we automate this? Maybe yes, maybe not. So my idea was to make a tool which can take a proof of concept crash and make an exploit, a working exploit from that, so to gain code execution from the crash. And if possible, without any manual interaction. So I wanted to make it completely automated. And I found a tool, or it was brought to my attention in one of the trainings. So a team developed the PYKD library. It's a Python library to interact with WinDGB. And it's written in Python. I like Python. I'm not a developer, so that's probably the easiest language I can just learn. And I like WinDGB, So this PYKD seems to bring the two together pretty well. So I actually made a tool, and I managed to automate this stuff, and I think I tested it with quite a few applications, and it seemed to work. So what it can do? It works for classic buffer overflows. So no DEP bypass. It can bypass ASLR in case there is a DLL or the main executable is not ASLR enabled. And then it can search that memory space for instruction. So that's one way to bypass ASLR, and it can do that if you want. It works for network and file-based exploit. That's important from automation part, because if you have a network-based exploit, it means that you start the application and then create your exploit, send your packets, and then crash the application. Now, if you have a file-based exploit, you actually need to create a file, open the application, and somehow load that file into the application to crash it. So the workflow is slightly different. And essentially, it will create a successful exploit from a crash. And it automates the entire process. So what I described in this slide, so basically this part is entirely automated. And you also don't need to manually start the process, attach it to WinDBG. You don't even need to attach you don't even need to start WinDBG for that, because luckily PYKD can actually start the process from a script, and from the script you can attach it to the debugger. So you don't really need to do anything. So what's the logic behind the actual tool? At first crash, it will look for the EIP overwrite location in the memory and find the offset for that in the buffer. Then it will look for registers which are pointing to your buffer. And then it will start going through the painful bad character finding process. So it will, first it will send all the characters to the program. It will check what went in compared to what we sent, and it will start removing characters from the buffer, what it finds not passing through. And then it will find a way to jump to your buffer, to your shell code, either with jump instruction, with call instruction, or whatever. So essentially it will search the memory space of the loaded DLLs for some good instructions. It will generate a shellcode, where for this it will just simply use Metasploit, and finally put it all together. So I have a demo. So as you see, it's sent in a buffer. It's something similar to what the pattern generate of Metasploit. And it will start to look to identify first the EIP, where is it, to find the offset. It's maybe seen. Then start to analyze the buffer, how much space we have in the memory, and it will keep starting and crashing the application. And right now, it will start to go through and identify all the bad characters that this application cannot take. So actually, this application is Minishare. This is a very old, some lightweight web server, which is really good for like experimenting and practicing buffer overflows. And it goes on. So at one point, it will find all the bad characters. Yes, it found it. Then it searched through all the loaded modules for some good instruction. and it made a list of them, and it will pick up the first one from the list. That's an arbitrary choice. And then it will generate shellcode. That takes some time. And essentially it will successfully pop up calc. So actually right now the shellcode is hard-coded to start calculator, but you can modify it to anything you would like. So how to use it? There is some pre-work you need to do for this to work. You cannot just take like any POC crash and give it to the tool and work from that. So you need to, so there is an exploit class I defined, and it has to be populated with the initial information. So how to crash the application. So essentially this is the function that has to be updated. You defined how you crash the application, and basically you define the space for your buffer. And this is the part, this buffer, what will be modified by the tool to actually generate the working exploit. And basically that's all. So that's the only function you need to create. Now, if you are lucky and the POC code is written in Python, then it's almost just a copy-paste to here. If not, then you actually need to create a Python exploit for it. And pretty much this is it. I have another video just to show. So this is another type, which is, so this one is a file-based exploit. So it will generate an MP3 list file for this application to crash. And essentially you can see that it will really do the same. So generating the patterns, identifying the registers, finding bad characters. And as you can see, this is all just one script. You don't really need to do anything other than, again, initially defining the exploit. And surprisingly, this is not something super difficult. So all this is about 600 lines of code to do it. So yeah, it can be further developed. I haven't done it because of lack of time, but along the same lines, you could add DP bypass, generating rob chains, or whatever. So you can find this up here on my GitHub page, along with those 3 codes for Minishare, this EasyRM application, and another one. So you can see what has to be modified or how to write a crash POC for this tool. That's all. Thank you.